Hi everyone, welcome to SATdecoded.com. In this video, we're going to be talking about absolute value, or what I like to call reflection functions. So this is basically a situation where they give you a graph of a function. For example, let's take a look at this graph on this side. And it says f of x equals x, and that's this line right here. I've given a few points right here, right here, right here, and right here. So if you give them ordered pairs, you know this point is 1, 1, this point is 2, 2, this point is -1, -1, and this point is -2, -2. So you know that the x and the y values are the same for every single point on this line, even the origin, 0, 0, which is exactly what this says, because remember f of x, that whole function, is considered our output, and outputs are y values. So what we really have here is an equation y equals x, which just means that whatever y is, x is going to be the same value as your y. So the question might ask you, given that f of x equals x, which is this graph right here, then what would the graph of f of x equal the absolute value of x look like? Well, if we really think about what this means, it just means, well, let's take a look at what f of x is first. We know it's an output, which we know is a y value. So what we really have here is a case of y equaling the absolute value of x. So I'm going to rewrite that right here. And what would you expect this graph to look like? Well, if the y value is equal to an absolute value, we know that absolute values can never be negative. Absolute values always have to be 0 or positive. So that means the y can never dip into the negative portion of the graph. And everything right here below this line, all, these two quadrants right here, they are when y are negative. So for example, you plot any point in these two quadrants and you find out what the ordered pair is. Like this one is probably 2, -1.7 or so. You see how the y value is a negative value? What about this point right here? This looks like maybe 1.5 for the x value, and maybe if we draw it maybe -3.5 for the y value. Again, the y is negative down here. These two are going to have negative y values as well. Everything below the line right here is going to have a negative y value. So because our y is equal to an absolute value of something, the y can never be negative. So that means our graph will never have anything in these two quadrants at all. So let's just take a look at f of x equals normal x, which is this line right here. If we redrew that line, it would kind of look like that. But there is an absolute value here. So that just means wherever the y value happens to be negative, we're gonna have to turn it positive. So where do we have a y section being negative? Well, it's gonna be this entire section down here, because remember I said there can't be any part of the graph in these two quadrants, and yet somehow this part is down here. So everything down here is unacceptable if we're looking for the absolute value. That just means we have to take the mirror image of this. We got to flip it up above the x-axis. We're just going to reflect it and turn all the y's into positive values, because that's exactly what absolute value does. So this portion of the graph was part of the original graph from the origin to what I'm tracing. So all the y values right here are already positive. So that means positive, if you take the absolute value of a positive number, it's still the same positive number. In other words, there's no change. So we're just going to leave this half of the graph alone. So our answer, what does the graph of f of x equal the absolute value of x look like, is just this V shape right here. This whole part right here on the bottom, which was part of our original graph over here, is gone. It just got reflected up over the x-axis, which effectively makes all the y values positive. So really this part of the graph shouldn't be here at all. And that is our answer, this V-shaped graph up above. All right, so let's take a look at another similar question now that you hopefully have a quick introduction to that concept. So let's say we have another graph here. They tell us this graph is g of x. They don't give us any tick marks. They also don't tell us what the equation of g of x is. All we know is this is the graph. So the question asks us to graph out what the absolute value of g of x looks like. Again, we know g of x as a function is an output, which is our y value. So we know this g of x inside is also a y value. So really, they're just asking us to graph out the absolute value of y. Well, again, absolute values can never be negative, so therefore everything has to be positive on our new graph for the y values. So again, nothing can be in this quadrant and nothing can be in this quadrant. Everything has to be in these two quadrants up here. I'm gonna erase these two x's because they kind of look like the variable x, which is not what we want to get confused with. Just remember that in our final answer, we can't have anything in these bottom two quadrants. So again, since we're reflecting everything that happened to be negative in the original graph over here up towards the positive y-axis, we're going to do the same thing here. So this part right here has all values for y that are negative. So that's unacceptable. This whole portion needs to get reflected up towards the positive portion. So I'm just going to redraw that portion right here. This part right here in our original graph also has y values that are negative. So that's also unacceptable and also needs to get reflected up towards the positive quadrant. So I'm going to redraw that right here. Now this part right here, all those points already have positive y values, or at least a 0 right here for the y value. So those are all acceptable for possible values, so we're just going to keep it exactly the way it is in our new version. Remember the absolute value of a positive number or the absolute value of 0 is still the same number, so there's no need for us to change it. So I'm just going to redraw it exactly the way it was. Same concept here. This triangle portion is, it just needs to be left alone because all of these points right here already have positive y values, or again, at least a 0. So I'm just going to redraw that right here, and that's our answer. This, these triangle shaped looking thing, that is what the graph of the absolute value of g of x looks like. Let's try another question. So what if we have this curve right here, and that curve is considered f of x? What does the graph of the absolute value of f of x look like? Again, it's the same exact concept. Wherever we have points on the graph, points on our original graph that have a negative y value, we got to turn those into positive y values, or at least 0 y values. So let's locate the areas that have negative portions for the y value, which is this part and this part. Notice how this bump right here and this curve right here are above the x-axis, which means this part and this part have positive y values, or again, at least 0 y values at these 3 points. So we're going to leave those parts alone. I'm just going to redraw those just as they are right here in our new graph. However, the parts below that I circled, those had negative y values, so we got to flip them over until they become positive. So this bump right here, I'm just going to reflect it into the positive zone. So I'm going to redraw that right here. And this portion also needs to get reflected into the positive zone. So I'm just going to redraw that right here. So this right here is what the final graph of the absolute value of f of x should look like. Some questions, they'll try to trick you and they'll say it doesn't include this portion and it also doesn't include this portion. They'll try to trick you and they'll just say the parts that were negative in our original portion, the parts I circled right here, they flip over and they think that this right here is our final graph. But that's completely erasing a huge portion of our original graph that needs to stay there. Another trick that they'll do is they'll have you reflect these two again, but these two, they'll try to just flip it upside down. And they'll try to do that. They'll do the opposite. But the problem is this is an absolute value, which just broke our rule. We can't have these two portions down here because those have negative y values, which are unacceptable. So again, we don't want that part and we don't want that part. We just want to put them back the way they were, just like that. Okay, so to give you a clearer picture, I will erase the parts we're not supposed to have. So just erase all of this and erase this part. Everything under the x-axis is unacceptable. So that's what our final graph should look like. Let me kind of erase too much, so I'm just going to redraw this back here. Kind of looks like that. Cool. So let's try one final question. So here it is, the question on the left-hand side. They give us a little graph, and they say the equation of the line above is y equals 2x plus 4. Which of the following is the graph for y equals the absolute value of 2x plus 4? Well, remember, this is a straight line, and straight lines fall into the y equals mx plus b formula. That's the slope-intercept form, where m is the slope of the graph and b represents the y-intercept. So it says 2x, so that means our slope is 2, which means rise 2 units and run 1 unit. And it says plus 4, so plus 4 is our y-intercept. As we can see here, 1, 2, 3, 4, it does intercept at the 4 right here. And since it has a slope of 2, if we start right here, go up 2 over 1, up 2 over 1, that fits perfectly. But we're really being asked, what does the absolute value of 2x plus 4 look like? So it's the same concept as the previous 3 questions we just did. We have to first locate the unacceptable area, and the unacceptable areas, again, are the parts where we have negative y values. Because if y equals an absolute value of something, y can never be something negative. So if we look at our original graph right here, this portion that I just circled is where we have negative y values. In other words, those are unacceptable values along this segment of the graph. So since we're taking the absolute value of these negative values, we just have to flip them over, reflect them across the x-axis, and turn them positive. So it's just going to look kind of like that, and it goes on forever. So which of these graphs, A, B, C, D, or E, does it look like? Remember, this portion from this point all the way up here, that still stays as part of our graph. That part, if you take the absolute value of that, is exactly the same value. So what we're looking for is this V shape with a vertex at this point. And this point is -2, 0. So if we look at our possible choices, B is the only one that does that. It has the vertex at -2, 0, which is exactly what we need, and it has the V. Notice how there's nothing down here because we don't want any negative y values. If you look at all the other graphs, well, at least this one, like all this right here, you see how that has negative y values. You see how this entire graph in choice E has negative values down here. You see this portion of the graph in choice C has a negative value. So because they have negative values and y is equal to an absolute value, and absolute values are never negative, choice A, choice C, and choice D are all wrong. Choice D has nothing in the negative portion for the y values. However, how did the graph suddenly shift up 4 points all of a sudden? There's no reason to. All we did is reflect the unacceptable portion over here. We still need this vertex right here at -2, 0, and somehow the vertex migrated from here all the way to here, which there's no reason to do that. So therefore, choice D is also wrong, and choice B is our final answer. So good luck. Hopefully this makes sense. This is how you reflect absolute value graphs. By the way, y, sometimes they'll use y instead of f of x, but remember, f of x or y are exactly the same thing, so don't get confused by that. Good luck, guys, and I'll see you in the next video.